Hello, this is Mr. Stansbury. I'm going to take you through the distance between 2 points notes. At the end of this, you should be able to say I can use the distance formula to find the distance between 2 points, and also I can use the distance formula to find information about polygons. Okay, so first things first, let's take a look at the distance formula. Okay, distance formula is the square root of the difference of the x's squared plus the difference of the y's squared. And that's when you get when you get 2 points, right? It's the distance between 2 points for this. Okay, the easiest way to help this make more sense is to take a look at an example. Example 1 says, find the distance between A and B. A is 5, -7. B is -2, 3. Okay, now you can assign these really whatever you want. If you want usually you do the first one, so that we'll call this x1, and this is y1, and then this is going to be x2, and this is going to be y2. So you're basically just finding the difference of the x's and the difference of the y's, squaring them and square rooting the sum of those. So anyway, we've got distance is going to equal square root. We're going to subtract x2 minus x1. So officially it's, you take this, subtract that. It doesn't really matter which one you subtract from which, because you're going to end up squaring it. So the negative sign, if you end up with 1, will end up going away either way. So anyway, I'm just going to follow the formula as we have it. So we've got -2 minus this x1 is 5. We're going to square that, and then we're going to add the difference of the y's. y2 is 3 minus -7. So 3 minus -7 squared. Okay, the biggest error I find in this is when you're like, we have 3 minus -7. Don't forget the double negative, which will end up turning that into a positive, right? So distance equals square root of -2 and -5 is -7 squared, and then 3 plus 7 is 10 squared. Okay, it is also important to make sure that we have -2 and -5 is -7. We've got to put that in parentheses because the -7 is going to get squared, not just 7 squared and the opposite of that. Okay, so we've got to make sure we do -7 times -7. So either way, if it's negative or positive, when you square it, we're going to end up getting a positive number out, right? Because -7 times -7, 7 times 7 is 49. The negative times the negative ends up being a positive, so we get positive 49, and 10 squared is 100. So we get that the distance is going to be the square root of 149. So then we just got to calculate that. Okay, so we get our calculator out here. We're taking the square root of 149. And we get 12.206. First, second, third significant figure. 0 tells the 2 to stay the same, so we're going to go with distance. It's 12.2, and there are no units on this. I'm just going to write 12.2 units, whatever it is. Okay? All right. Let's take a look. Oops. There we go. Example 2. Points A, B, and C form a triangle ABC. Use the distance formula to classify the triangle as equilateral, isosceles, or scalene, and then determine whether the triangle has a right angle. Okay, so in order for us to know if it's equilateral, isosceles, or scalene, we need to know the lengths of each side. Okay, so what we're going to have to do is we're going to have to find the distances between all of those. Okay, so you don't have to do this, but I'm kind of a little bit more visual, so I'm going to just kind of sketch these somewhat on a graph, just so I kind of get an idea of what things look like here. So we're at 5, -3, so we'll call that A is at 5, -3. B is at 1, 8, so we'll call that B, which is at 1, 8. And then we've got C at -6 and 1. So there's our C at -6 and 1. And then we can actually make ourselves a little triangle here. Again, you do not have to draw it out. For me, it just makes it a a little bit nicer. I can see what I'm doing instead of just going through plugging everything into a formula. Okay, so let's find, say, the distance between A and B first. So that's this here. So distance from A to B, distance of segment AB is going to be, let's see, we're usually taking the x2 minus the x1. So 1 minus 5 squared. And then we're going to have the difference of the y's, 8 minus negative 3 squared, right? Those turn into positives. So we have the square root. So let's put d for distance there. 1 minus 5 is negative 4 squared. And 8 plus 3 is 11 squared. Negative 4 times negative 4 is positive 16. 11 squared is 121. Add those together and we get, what's that, 137. So now we're just going to take the square root of 137 and we get 11.704. So 1, 2, 3, 0 tells the 7 stay the same, so we're going to go with 11.7. Okay, so this is 11.7, we're calling it. Distance of, let's go with AC, is going to be, here's A and here's C, so we got 1 minus, oh, sorry, the x's, sorry, is what we're supposed to start with. Negative 6 minus 5 plus 1 minus negative 3. All right, and so that gives us negative 11 squared plus 1 minus negative 3 is 1 plus 3 is 4 squared. So that gives us square root negative 11 is negative 11 squared. 11 times 11 is 121, and the negatives turn in, two negatives multiplied together give us a positive. And then 4 times 4 is 16. And look, that's exactly what we had over here. So we get distance is the square root of 137. So then that we just calculated that out earlier. So the distance is going to be 11.7. Okay, so let's see, that was I wrote this in the wrong spot, which actually ends up being the right spot because here's AB. AB 11.7 is where we were supposed to write that, or I was supposed to write that, sorry. AC is this one right here, that's also 11.7, so now we just got to figure out what CB is. Okay, so let's do that. Distance from C to B is, let's see, 1 minus 8 squared plus negative 6 minus 1. Right, so distance is going to equal negative 7 squared plus another negative 7 squared. So that is, let's see, it's 49 and 49, so that distance is going to be the square root of 96, right? So square root 96, no, not 96, 98. Sorry about that. 98, there we go. And we get 9.899. So 1, 2, 3, 9 tells the 9 to get bigger, which turns it into a 10, so that's 9.90. So the distance here is 9.90. So this here is 9.90. So now that we have the three sides all figured out, we have two that are same and one is different, so that means it's going to have to be isosceles, right? And then determine whether the triangle has a right angle. So what we'd have to do on that, that's where we would do, does a squared plus b squared equal c squared? Our two longest sides would have to be the hypotenuse, since those, since those are exactly the same, there's no way that we could put 11.7 in here and then 11.7 there and a 9.9 there and have those two equal each other. So it does not have a right triangle. So no, sorry, it does not have a right angle. No right angle would be our answer. Okay, so it's isosceles and no right angle. So you can find out a lot about a triangle when you have the endpoints, the coordinates of each endpoint. We can figure out a fair amount of information about that triangle using our distance formula. All right, if you have any further questions, please feel free to ask in class. Thanks.